Centripetal force is the force directed toward the center of an object's curving path of motion. So if you were to twirl a string over your head that has a ball attached to the end of it, that ball is going to travel in a circle. So if I was going like this, the ball would go in an exact circle around my head. And so what we have here, attached to the ball at the end here, see this string could be pointed in multiple different directions and has a ball attached to the end of it. So what we have here is centripetal force, which is the force that's pulling it towards itself. We also see this in the solar system. So we have the sun right here, and then we have planets moving around it. And so this planet is going to move in a circular pattern, in a circular motion all the way around it. But notice there's no string there. So at this time, gravity is what's providing the centripetal force. Here, it's the tension and the rope that's always pulling the ball towards the middle of it. But you notice that the planet never comes crashing into the sun, and the ball never all of a sudden just stops over your head. It continues to go in a circle. And the reason for that is because of this other type of force, which really isn't a force. So that's kind of confusing. But we have centrifugal force, which is not an actual force, but rather it's just the terminology we use to describe an object's inertial resistance to any change in its motion in a straight line. So it's an object's inertial resistance to any change in its motion in a straight line. So again, I go back to the diagram I had earlier. So this is your hand twirling the string over your head in a circle. And actually, I'm just going to cross that out because that was such a terrible circle. All right, that one's a little better. And so at any point the ball is along this circle, if all of a sudden the ball were to break off of the string, it would continue, or it would go in a line tangent to the circle. So all of a sudden, if the ball broke off the string, it wouldn't continue to go in a circle. It would go in a line tangent to the circle. So that means 90 degrees too. So say the string is going to the ball right there. It's going to go 90 degrees in a different direction. So it's going to go straight. And so at any point, this ball is really, that I'm twirling over my head, wants to go in a straight line. But it can't because of this centripetal force that's trying to pull it in. And so the centripetal force is trying to pull it in, but remember we have the law of inertia, which is Newton's first law. And the law of inertia is that an object that is at rest wants to stay at rest, and an object that's in motion wants to stay in motion. So in this case, we're dealing with an object in motion. It wants to stay in motion at the same speed in the same direction that it was already going. And so it really just wants to keep on going in a straight line, but we have the centripetal force that's fighting against that. So we have this inertial resistance against the centripetal force, which we call centrifugal force. And so it's not really a force, it's just inertial resistance, but we call it a force because it behaves and acts like a force in many ways. And so an object traveling in a circle or moving around a curve appears to experience an outward force pushing it away from the center of rotation or movement. And so we could describe it as simply inertia in action as described by Newton's first law of motion. And it applies to all bodies moving in a circle. So that's an explanation of centrifugal and centripetal force.